we have Craig Hardgrove, who will be talking to us about LunaH-Map.
Hi, this is Craig Hardgrove. I'm an assistant professor at the ASU School of Earth and Space Exploration, and I'm the principal investigator for LunaH-Map, the Lunar Polar Hydrogen Mapper mission. We were the first simplex mission selection back in 2015, and later on in this workshop, you'll hear from the other simplex selection, which was more recently selected, Lunar Trailblazer. So these are, in the first instantiation of the simplex call, these are very small spacecraft. So we're a 6U, sort of the size of 2 large cereal boxes slapped together. And that's an image of the completed flight spacecraft. I'm getting some feedback. Is that from me or somebody on the line?
If anybody's on the line, they should mute themselves.
Next slide, please. So we are manifested along with 12 other CubeSats on SLS Artemis 1, and our mission is to map South Pole hydrogen enrichments within and outside of the permanently shadowed regions at spatial scales of around or less than 20 square kilometers. And in order to do so, we needed to design a new type of neutron spectrometer for small spacecraft, and the spacecraft will have its own navigation and communications back to Earth using the Deep Space Network. So we will navigate into lunar orbit after deployment from the SLS. So it's a tall order for such a very small spacecraft, but I'll show you a bit about how we plan to do that. If you go to the next slide. So this is actually some of the motivation for the mission. This is a neutron-derived hydrogen map of the south pole of the moon made with Lunar Prospector's neutron spectrometer. Fairly coarse spatial resolution. Yeah, that's the right slide. And one of the unique things about neutron spectroscopy is it provides an integrated view of the top meter of lunar regolith. And LunaH-Map will be focusing primarily on epithermal neutrons, which are down to about 40 centimeters or so. So we're getting a view of more of the bulk as opposed to just the surface or optical surface of the lunar regolith. And sort of notoriously, these measurements are not known for the. I'm sorry, what was that?
2 minutes left.
Okay, they're very coarse spatial resolution. So if you go to the next slide, these are sort of what we're planning to focus on, the regions of focus for LunaH-Map. One of the things we want to map is resolving the hydrogen within permanently shadowed craters as well as outside of permanently shadowed craters to understand if the contributions from previous neutron measurements with their coarse resolution was perhaps incorporating hydrogen within the permanently shadowed regions in some of those areas in the previous maps that showed enrichments in the areas outside of PSRs. Okay, let's go to the next slide. This is our trajectory design. We deploy from SLS in that little number 1, and we go out to the weak stability boundary and come back. We use a little ion propulsion system, which I put in the upper right. Provides a very weak thrust, but it's very high ISP. So we have enough fuel in about the size of a tissue box propulsion system to get ourselves back into lunar capture. Depending on the Earth, Moon, Sun position of the SLS launch, that can take anywhere up to a year. But as short as 4 to 5 months, depending on the launch trajectory. Next slide. The other thing I'd point out is we fly very low over the South Pole, so we'll make
about 30
our maps
seconds.
only over the South Pole. Okay. And this is the ground tracks. You go to the next slide. And this is what one of those ground tracks looks like, showing the PSR contribution of the neutron signal reaches about 80% just for Shoemaker. The altitude shown on the bottom right, if you go to the next slide. And this is what we predict for our possible mapping capabilities for the mission using some example hydrogen populations on the left. We do show that LunaH-Map can resolve those distributions individually in most of the permanently shadowed regions. If you go to the next slide. That's
it's
just
already 5
summarizing
minutes.
what we. Yep. Next slide. This is the neutron detector. Next slide. It's modular, and then this is the flight unit. Next slide, please. And we'll be operating the spacecraft from ASU. Next slide, please. Just a picture of the completed assembled spacecraft, which was done back in April. And here's our flat sat and some of the activities that the spacecraft team is working on getting ready for launch or delivery in November of this year. That's it. Thank you.